Hello and welcome to 5-Minute Math. Today we are looking at the 6th grade concept of equations for area. This is standard 6.8C in the great state of Texas, and we are using item number 23 off the 2021 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. So the length of the base of a parallelogram is 14 centimeters. So let's draw that here. This might not be perfect, but we'll attempt to draw a parallelogram here. And it doesn't actually tell you what kind of parallelogram it is, but we'll just think it's like the one that we normally imagine, 14 centimeters. And the corresponding height is h. All right, so it's unknown. Now, here's the thing with height of a parallelogram. You're not going to use either of the sides because the height needs to be perpendicular to the base. So what you're going to get is you're going to get a little dotted line right here. It's going to have a little right angle symbol right there, and then you're just going to get your measurement. So h. All right, so we've got 14 centimeters, we've got h. Which formula can be used to find a, the area of the parallelogram, in square centimeters? Now here's the strange thing. If you are using your resources, you are going to your formula chart. And when you go to the formula chart, you are going to see under the word area, you are going to see this. It's going to say rectangle or parallelogram, which is what they gave us. And you're going to get the same formula. A equals base times height. Now, we get that if we're dealing with a rectangle, right? Base times height, so you've got 10, you've got 5, that's easy. 5 times 10 makes 50 units squared, right? That's easy. We've been dealing with that since 3rd grade. We've been looking at area of squares and rectangles. But how is it the exact same thing for parallelograms? Well, we have to do a little bit of imagination. You can see what actually works. Let me draw this right here. Let me draw another line on my parallelogram to represent the height on this side. You notice that if I made this a solid line, that'd almost be like a trapezoid. Like I've got some good right angles here, don't I? The problem is I've got this part right here that's kind of sticking out. And the problem is I'm missing something on this left side as well. I've got a blank area. So what you can do with a true parallelogram, remember it's got to be parallelogram, so that means this side is parallel to this side, and this side has to be parallel with this side. So it has to be a true parallelogram. You can actually take this side, cut it off, and mentally rotate it and bring it over here. And guess what you're going to get? You're going to get that missing piece. It's going to be right there. So if we can get rid of this right here, flip it over to this side, look what you have. It's a rectangle. So that's why you can use the exact same formula, A equals BH, for either a rectangle or a parallelogram. So that makes this a pretty simple problem. We're looking for A equals BH, and the base is 14. So look, they already give us the answer. It's right here. It's B. So what are some of these other ones? Well, this A is, you're just adding those two. If you were to do 14 plus H plus 14 plus H, I mean, at least you can get the perimeter, maybe, but this H really isn't even the perimeter. It's the height. It's not the outside. So A just doesn't make any sense. It doesn't relate to anything we know, but it's just an attempt to do something, add the 14 and the H. Now the C might look familiar because you've got this 1/2 and you're like, oh, I remember that 1/2 base times height. Yeah, 1/2 base times height. That would be wonderful if you were a triangle. That's what you do for triangle, is 1/2 base times height. And then C is kind of is wrong, and D is kind of half triangle. It's kind of how you find a trapezoid, but our answer here is B.